According to the National Electrical Code, specifically NEC 230.94 and B, there are stipulations for disconnecting means in multiple buildings or occupancies. 230.94 states that where more than one building or structure is supplied from a common service, the disconnecting means for each building or structure shall be grouped at one location. 230.94b addresses multiple occupancy buildings directly, stating that a main disconnecting means shall be provided for each separate occupancy. Now let's apply this to a scenario where there's an existing building divided into two tenant spaces, each with its own service. The disconnects for these services are located back to back on an exterior wall. In this arrangement, the setup complies with NEC 230.94 because the disconnecting means for each occupancy are grouped at one location. Based on this understanding of the code, both disconnects do not necessarily need to be relocated to the exterior, provided they already meet the grouping requirement as described. Now let's delve deeper into the NEC to provide more context and clarity. Article 230 covers services in general. A service is defined as the conductors and equipment used to deliver electric power from the serving utility to the wiring system of the premises served. It's crucial to understand this basic definition before applying any specific code rules. The NEC emphasizes safety and accessibility when it comes to service equipment. This is why the concept of a readily accessible disconnecting means is so important. A readily accessible disconnecting means ensures that in the event of an emergency, power can be quickly and safely shut off to a building or occupancy. When we talk about grouping disconnecting means, the intention is to create a single, easily identifiable location where all the service disconnects are located. This is particularly important in multiple occupancy buildings where it might not be immediately clear which disconnect serves which tenant. The rule in 230.94b regarding a main disconnecting means for each separate occupancy is designed to prevent confusion and ensure that each tenant has control over their own electrical supply. In a situation where a building is divided into multiple tenant spaces, each tenant should have the ability to disconnect their service without affecting the other tenants. This is not only a matter of convenience but also of safety. For example, if a tenant needs to perform electrical work within their space, they should be able to de-energize their service without disrupting the power to the entire building. Now, let's consider some additional factors that might influence the interpretation of these NEC rules. Firstly, local amendments to the NEC can vary from jurisdiction to jurisdiction. It's essential to consult with the local authority having jurisdiction, often referred to as the AHJ, to determine if there are any local rules that supplement or modify the NEC requirements. Secondly, the specific layout of the building and the location of the service equipment can play a role in determining code compliance. For example, if the disconnects are not only back-to-back, but also readily accessible to all tenants, this would further support the argument that the installation is compliant with the intent of the NEC. However, if the disconnects are located in a locked room or otherwise difficult to access, this could raise concerns about code compliance. Thirdly, the presence of other electrical equipment in the vicinity of the service disconnects can also be a factor. The NEC has specific requirements for working space around electrical equipment, and these requirements must be met regardless of whether the disconnects are located indoors or outdoors. Sufficient working space ensures that electricians and other qualified personnel can safely perform maintenance and repairs on the equipment. Now, let's address a common question that arises in these situations. Does the NEC require all service disconnects to be located outdoors? The answer is no. The NEC does not explicitly require all service disconnects to be located outdoors. However, there are circumstances where an outdoor disconnect might be necessary or desirable. For example, if the building is located in an area that is prone to flooding, an outdoor disconnect might be required to protect the equipment from water damage. Additionally, some utilities require an outdoor disconnect as part of their service connection agreement. Now, let's discuss some potential challenges that might arise when applying these NEC rules in practice. One challenge is determining what constitutes a separate occupancy. In some cases, the boundaries between tenant spaces might not be clearly defined, which can make it difficult to determine where one occupancy ends and another begins. Another challenge is ensuring that all tenants have access to their service disconnects. If the disconnects are located in a common area, it's important to ensure that all tenants have a key or other means of accessing the disconnects in an emergency. Finally, it's important to remember that the NEC is not a design manual. The NEC provides minimum safety standards, but it's up to the electrical designer and installer to ensure that the electrical system is properly designed and installed to meet the specific needs of the building and its occupant. In summary, when dealing with service disconnects in multiple occupancy buildings, it's essential to carefully review the NEC requirements, consult with the local HJ, and consider the specific layout and conditions of the building. By taking these steps, you can ensure that the electrical system is safe, reliable, and code compliant. Now, let's dive into some specific examples to further illustrate these concepts. Imagine a strip mall with 5 different tenant spaces. Each tenant space has its own meter and service disconnect. The disconnects are all located in a row on the exterior wall of the building. In this scenario, the installation would likely be considered compliant with NEC 230.94 because the disconnects are grouped at one location. However, let's say that 2 of the tenant spaces are combined into a single larger space. In this case, it might be necessary to consolidate the 2 service disconnects into a single disconnect to serve the combined space. This would ensure that the electrical system is properly sized for the new load and that there is only one disconnect for each occupancy. Now let's consider a different scenario. Imagine an apartment building with multiple dwelling units. Each dwelling unit has its own meter and service disconnect. The disconnects are located in individual electrical panels inside each apartment. In this case, the installation would likely be considered compliant with NEC 230.94b because each separate occupancy is its own main disconnecting means. However, it's important to ensure that the disconnects are readily accessible to the occupants of each apartment. If the disconnects are located behind locked panels or are otherwise difficult to access, this could raise concerns about code compliance. Now let's talk about the importance of proper labeling. The NEC requires that all service disconnects be clearly labeled to indicate the area or equipment they serve. This is especially important in multiple occupancy buildings, where it might not be immediately obvious which disconnect serves which tenant. Proper labeling can prevent confusion and ensure that the correct disconnect is de-energized in an emergency. The labels should be durable and weather-resistant, and they should be securely attached to the disconnect enclosure. The labels should also be easy to read and understand, even in low-light conditions. In addition to labeling the disconnects themselves, it's also a good practice to provide a directory or map that shows the location of all the service disconnects in the building. This directory can be posted to a common area, such as the lobby or electrical room, to help tenants and emergency personnel quickly locate the appropriate disconnects. Now let's address the issue of overcurrent protection. The NEC requires that all service conductors be protected against overcurrent by fuses or circuit breakers. The overcurrent protection devices must be properly sized to protect the conductors and equipment they serve. In a multiple occupancy building, it's important to ensure that each tenant's service is protected by its own set of overcurrent protection devices. This prevents a fault in one tenant space from affecting the electrical service to other tenants. The overcurrent protection devices should be readily accessible and clearly labeled. They should also be inspected and tested periodically to ensure that they are functioning properly. Now, let's talk about the importance of grounding and bonding. The NEC requires that all electrical systems be properly grounded and bonded to provide a safe path for fault current to return to the source. Grounding and bonding help to prevent electrical shock and fire hazards. In a multiple occupancy building, it's important to ensure that each tenant's service is properly grounded and bonded. This includes grounding the service equipment, bonding the metal enclosures, and connecting the grounding electrode system to the building's structural steel or grounding grid. The grounding and bonding system should be inspected and tested periodically to ensure that it is functioning properly. Now let's address the issue of surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning strikes, power outages, and other transient events. The NEC recommends the use of SPD at the service entrance of all buildings, especially those that are located in areas that are prone to lightning strikes. In a multiple occupancy building, it's important to consider installing SPD at each tenant's service entrance to protect their sensitive electronic equipment. The SPD should be properly sized and installed in accordance with the manufacturer's instructions. Now, let's talk about the importance of regular maintenance. Regular maintenance is essential to ensure that the electrical system in a multiple occupancy building is safe, reliable, and code compliant. Maintenance tasks should include inspecting and testing the service disconnects, overcurrent protection devices, grounding and bonding system, and surge protection devices. Any damaged or worn component should be repaired or replaced promptly. A qualified electrician should perform the maintenance tasks. The frequency of maintenance should be determined based on the age and condition of the electrical system, as well as the environmental conditions to which it is exposed. Now, let's address the issue of renovations and alterations. When a building is renovated or altered, it's important to ensure that the electrical system is brought up to current code requirements. This may involve replacing outdated equipment, adding new circuits, or upgrading the service entrance. In a multiple occupancy building, renovations and alterations can be particularly challenging because they may affect multiple tenants. It's important to coordinate the work with all affected tenants to minimize disruption and ensure that the electrical system remains safe and reliable. Now, let's talk about the importance of documentation. Proper documentation is essential for maintaining a safe and code-compliant electrical system. Documentation should include a record of all electrical work that has been performed in the building, including permits, inspections, and test reports. The documentation should also include a detailed diagram of the electrical system showing the location of all service disconnects, overcurrent protection devices, grounding and bonding points, and surge protection devices. The documentation should be kept in a safe and accessible location, and it should be updated whenever changes are made to the electrical system. Now, let's address the issue of emergency procedures. It's important to have well-defined emergency procedures in place to deal with electrical emergencies such as power outages, electrical fires, and electrical shocks. The emergency procedure should include instructions on how to safely disconnect power to the building, how to evacuate the building, and how to provide first aid to victims of electrical shock. All tenants should be familiar with the emergency procedures. Emergency contact information, including the phone numbers of the local fire department, police department, and utility company, should be readily available. Now, let's talk about the importance of ongoing training. Ongoing training is essential for ensuring that all personnel who work on the electrical system in a multiple occupancy building are properly trained and qualified. Training should cover topics such as electrical safety, code requirements, and troubleshooting techniques. Training should be provided by qualified instructors. Refresher training should be provided periodically to ensure that personnel stay up to date on the latest codes and practices. Finally, let's emphasize the importance of working with qualified professionals. When it comes to electrical work, it's always best to work with qualified professionals who have the knowledge, skills, and experience to do the job safely and correctly. A qualified electrician can help you to design, install, and maintain a safe and code-compliant electrical system. A qualified electrical inspector can help you to ensure that your electrical system meets all applicable code requirements. By working with qualified professionals, you can protect yourself, your tenants, and your property from the hazards of electricity. Now, to reiterate the key takeaways from this discussion on NEC compliance for service disconnects in multiple occupancy buildings, consider these points. Firstly, always consult the latest edition of the National Electrical Code and any applicable local amendments. Secondly, understand the definitions of key terms such as service, disconnecting means, and readily accessible. Thirdly, ensure that the disconnecting means for each occupancy are grouped at one location or that each separate occupancy has its own main disconnecting means. Fourthly, provide clear and durable labeling for all service disconnects, indicating the area or equipment they serve. Fifthly, ensure that the service conductors are protected against overcurrent by properly sized fuses or circuit breakers. Sixthly, ensure that the electrical system is properly grounded and bonded. Seventhly, consider installing surge protection devices to protect sensitive electronic equipment. Eighthly, perform regular maintenance on the electrical system, including inspecting and testing the service disconnects, overcurrent protection devices, grounding and bonding system, and surge protection devices. Ninthly, when renovating or altering a building, ensure that the electrical system is brought up to current code requirements. Tenthly, maintain proper documentation of all electrical work performed on the building. 11thly, develop and implement well-defined emergency procedures for dealing with electrical emergencies. 12thly, provide ongoing training to all personnel who work on the electrical system. Finally, work with qualified professionals who have the knowledge, skills, and experience to do the job safely and correctly.